This is the second part of the second lecture of week 9, where we consider some examples of finding inverse Laplace transform. The first thing I want to tell you, you have the table of Laplace transform in your book at the end of the paragraph 7.2, and this table should be always with you when you work with Laplace transform and inverse Laplace transform. This table also will be given to you on the final exam, so you don't have to learn the formulas by heart. And as for Laplace transform, we have special just formula for finding it. Here for inverse Laplace transform, we just can do this by inspection using this table. Let's see how it works. Assume that we're given Laplace transform of some function is 2 over s cubed, and we need to find the original function. So what we do, we go to the Laplace transform table, we look at the right side and try to find a function which is appropriate to this function, which is similar to this function. For example, if you go through them, the only one which is good is this thing. So s to the power 3, it means that n must be 2. And 2 factorial also in the numerator. So the original function was, this is t squared. Okay? So next example, assume that we're given Laplace transform of a function is 3 over s squared plus 9. Again, we go through the table and we try to find similar expression in the right column of this table. And similar expression we can see for sine bt, for cosine bt, the denominator is s squared plus b squared, s squared plus b squared, what we have here. So this is 3 over s squared plus 3 squared, so b should be 3. And in numerator, we have b here or s. Of course, in our case, we have b, so we will use this formula for sine bt. So the original function f of t was sine, and b is 3 in our case. Also, let's look at example like this. F of s is s minus 1 over s squared minus 2s plus 5. Again, we have to look at our table and find something similar. So we have s squared in the denominator. Let's try to find where we have s squared in sine and cosine, and also in these two things. And here we have s minus a squared, so it means that sometimes we need to try to complete square of the denominator. Let's do this. S minus 1, and this one is s minus 1 squared, and in this 5 we have just 4 left. So now it's quite similar to one of this. Let's also rewrite it as s minus 1 over s minus 1 squared plus 2 squared. So now it's completely similar with b equals 2. And in numerator we have b or s minus a. In our case we have s minus a. So a is 1, b is 2. Exactly this formula we need. So the function f of t is e to the t cosine to t. So this is inverse Laplace transform of this fraction.